Good morning, everyone. We have learned the ceramics, the crystal structures of ceramics, and now we want to learn the applications and processing of ceramics. And here are today's objectives. First, we want to learn on how to classify ceramics. We have many ceramics, how to classify them. We want to learn some applications of ceramics. The ceramics have been used widely in our daily life in various industrial applications. First, talk about point defects in ceramics in our last class session, and we talked about these point defects already, and it does not hurt to refresh your memory. And there are Frankel defects, and this Schottky defect. So Frankel defect, it means that a cation vacancy along with a cation interstitial pair. So this is that means we have one cation vacancy, and then we have cation interstitial. This is a pair. And Schottky defects, it means that a paired set of cation and iron vacancy. And we talk about this one. This is Schottky defect. And so this is vacancy. So that means this is at this location, the cation, the smaller sphere, smaller ion, the mist disappears for some reason. And here, the bigger sphere or big atom, and which is the iron, is also missing. So this is a pair of cation and iron vacancy. So this is a Schottky defect. Another one, the first one is then the Frankel. Frankel with the Frankel defects. So means previously, either of these is the two cations, and they are located here. But for some reason, this guy moved from this location to this new location. So this is called Frankel. This is called Schottky defect. And we also introduced the two equations to calculate the concentration of defect and using these two equations. And then we talk about the classification of ceramics and ceramic materials, and we have 6 big categories. And so first one is glasses, and they used for optical, composite, reinforced containers and household. And the clay products, second category is clay products. For example, weatherware and structural. And refractories and includes bricks for high temperature, for example, for furnaces to make the furnaces. Abrasives here, and sandpaper. We can, if you have worked in the machine shop, and you will know how to use the grinding machine, and this is the sandpaper or just a grinder, and cutting tools and polishing tools. And so this is another category is cements and cements, composites, and the structural. And in our daily life, we use the cement a lot and for building build our houses and make the pavement. A lot of this is the structures. Another category is advanced ceramic and ceramics. For example, and we use these advanced ceramics to make the engines, rotors, valves, bearings, and sensors. So I want you guys to know we have 6 different categories, and then these categories and has several the applications. You should know that. And so we talk about glasses first. This first category, okay, they are non-crystalline, the silicates, the containing other oxides, notably the calcium oxide, this is sodium oxide, and this is a potassium oxide along with aluminum oxide. So these are glasses. The soda lime glass consists of approximately 70% of silicon dioxide, the silicon O2. The balance being mainly this is sodium oxide soda and this calcium oxide lime. So the soda lime. The two prime assets are optical transparency, and this is the relative ease with which they may be fabricated. And so this is the good thing for these glasses: the optical transparency, the glass windows, the glass utensils we use. All they are from this is glasses. And this is the second slide. This is the compositions and characteristics of some of the common commercial glasses. So fused silica, 96% of silica, and borosilicate, and container soda lime, and fiberglass, optical flint, and glass ceramic. So you can see they have different compositions and they have characteristics and applications, and for each of these glasses. And questions regarding this slide. And the second one, then we talk about these most inorganic glasses can be made to transform from a non-crystalline state to one that is crystalline by the proper high temperature heat treatment. So this process is called crystallization. The fine-grained polycrystalline material is called the glass ceramic. The formation of this small glass ceramic grain is a phase transformation involving nucleation and growth stages. So this is the glasses. And so here it shows the phase transformation and continuous cooling transformation diagram for the crystallization of a lunar glass. So this is composition, and also superimposed on this plot are two cooling curves. So this is two cooling curves, labeled 1 and 2. So this is 1 and this 2. So you can see here is we see this one in phase diagram for iron and cementite. Here is also, this is the crystallization begin curve. This is crystallization end curve. So you can see if the cooling rate is high enough, and so they will go there directly and go here, okay? And you will not have crystallization. But for here, if the cooling rate is lower than this critical cooling rate, and the curve will intersect this crystallization begin curve and also this crystallization the end curve, and you will end up with glass ceramic. And a nucleating agent. Okay, so sometimes we need some agent, something. For example, titanium dioxide is often added to the glass and to promote the crystallization. The presence of a nucleating agent shifts the begin and end transformation curves to shorter time. So that is the function of the nucleating agent. You should know that. I will not ask you guys to memorize, but you should know what is the purpose to use some nucleating. As the name suggests, this guy promotes the nucleation. As a result, and this guy can facilitate the crystallization. Any questions regarding this slide? No question. And then we talk about these glass ceramics materials, and they have the following very, very beautiful temperatures. For example, relative high mechanical strength, because it's brittle, I'm talking about compressive, okay, compressive, low coefficients of thermal expansion, and to avoid the thermal shock and thermal expansion. Thermal shock means that if we elevate the temperature, and so this sample will expand substantially. If this is the case, we could say this guy has higher coefficient of thermal expansion. So higher coefficient of thermal expansion of some material is a better thing for this material, and they call it thermal shock, because if we elevate the temperature, and so this guy expands substantially, then if we lower temperature, this guy shrinks substantially. So this is thermal shock. Another beautiful property is relatively high temperature capabilities. So this is the glasses usually have very high melting temperature, and so that's the reason, one of the reasons that we use glasses in our daily life for the utensils. And good dielectric properties, so good dielectric properties, and also good biological compatibility. And so that means these glasses can be used for some bio applications. And clay products. And then we talk about the second category, clay products, and structural clay product and the wet wares. And structural clay products include the building bricks, tiles, and sewer pipes, application in which structural integrity is very important. The wet wares become wet after high temperature firing. So that's the reason this small category of material they are named wet wares. Ceramics applications, right? So first, they have been used as a die. So die blanks, so need wear resist properties. So you can see here, so this is a die, so this is a die, so this is a material, and we have a very heavy duty machine that can pull this material and provide a tensile force for this sample, and then this is the sample can go through this orifice here between these two dies, and then we can just reduce the thickness. You can see original thickness to the desired thickness AD. So this die so these ceramics can be used as this die. And the die surface, 4 micrometer polycrystalline diamond particles that are centered onto a cemented the tungsten carbide substrate, and we use this coated. It is not a monolithic. This is not a single the ceramic material, but there is a material, some other material, but there are some the thin coat. For example, 4 millimeter polycrystalline diamond particles, and they are centered onto a cemented tungsten carbide substrate. Polycrystalline diamond gives uniform hardness in all directions to reduce wear. So this is very good, because polycrystalline means that microscopically, and so they have the uniform hardness along all these directions. Any questions regarding this slide? And then we talk about another very important applications. So ceramics can be used as one of the most important cutting tools. If you have already taken manufacturing processes, or you are taking manufacturing processes course concurrently, I think you have, we have already, I teach the manufacturing processes course as well in the spring semester. If you have already taken this course, I would say maybe you have already know how these ceramics have been used as cutting tool materials. And for their tools, for grading glass, the tungsten carbide ceramics, for cutting silicon wafers, and for oil drilling. And so these oil drilling blades, these single crystal diamonds, the polycrystalline diamonds in a resin matrix. And so you can see, because of the high hardness of these ceramics, so that's the reason they can be used as the cutting tool. The materials manufactured single crystal or polycrystalline diamonds in a metal or resin matrix. So polycrystalline diamond resharpened by micron fracturing along cleavage the planes. And another application for the ceramics materials is to use ceramics to make the sensors. And for example, zirconium dioxide can be used as an oxygen sensor. The principle why this guy can be used as an oxygen sensor. The principle is that increase diffusion rate of oxygen to produce rapid response of sensor signal to change in oxygen the concentration. So here, okay, so this is the gas with unknown higher oxygen content. So this is a sensor. This is a reference gas at fixed oxygen content. This is reference. So the voltage difference the produced. This is positive, this is negative, and so you can see add this calcium impurity to zirconium dioxide, right? So increases oxygen vacancies and increases oxygen diffusion rate. So operation, the voltage difference produced when oxygen and cations, oxygen ions diffuse from the external surface through the sensor to the reference gas surface. A magnitude of voltage difference is proportional to the partial pressure of oxygen at the external surface. So here, if we add this calcium ion as impurities here, a substitute of calcium ion removes a zirconium ion and an oxygen ion. And then we talk about the refractories, and that is another category of ceramic materials. As the name suggests, refractory, and they have very, very high melting temperature. So materials to be used at high temperature, for example, in high temperature furnaces. And consider the silicon dioxide, aluminum dioxide system, silica refractories, silica rich, small addition of alumina, depress melting temperature, the phase diagram. So this is the silica is very, very rich in our nature. Okay, so as long as we add some small additions of alumina, we can have this diagram. And so this is I introduced this phase diagram to you in the previous class. Be very, very careful. You can see it's some cristobalite, mullite plus cristobalite, mullite, alumina plus mullite, alumina plus liquid. So this is liquid. So here is the liquidus curve, and liquidus curve. And here is the moonlight. This is moonlight. Okay, moonlight is the combination of aluminum oxide and silicon dioxide. So advanced material ceramics, that is another category. Materials for automobile engines. Advantages: operate at high temperatures and high efficiency, and low frictional losses. Why? Because it has very, very high hardness, and frictional losses will be very, very low. And operate without a cooling system. You do need to have cooling system because this guy has very, very high melting temperature. No worry about the cooling, the overheating, and lower weight than the current engines. Yeah, ceramics, and ceramics have less lower weight than the currently used metal engines. And so this is advantages. Disadvantages. And ceramic materials, they are brittle. Right? Brittle. This is very, very the better thing sometimes. Difficult to remove internal voids, these parts that weaken structure. And ceramic parts are difficult to form and machine because it's itself they are very, very hard. And potential candidate materials, silicon nitride and silicon carbide, zirconium oxide. So this is for 3 guys can be used as a coating material for the cutting tools. And why I emphasize this part, because I'm a manufacturing guy. Okay, so possible engine parts, the engine blocks and the piston, the coatings. Advanced materials. Okay, some advanced materials can be used as the material for ceramic armor and to protect our soldiers or protect our law enforcement officers. For example, the components, okay, we have outer facing plates, and we also have a backing sheet. And properties of materials, on face plates, the hard and brittle, on fracture, high this velocity projectile. Right, so this fracture high velocity projectile. For example, aluminum oxide, this B4C, silicon carbide, titanium, this TiB2. Backing sheets, soft and ductile, deform and absorb remaining energy. They are made of aluminum, synthetic fiber laminates. So this is more topics, laminates, and we can talk about the fiber laminates in several class sessions. But I will not talk about this here now. And so this is ceramic armor. So this is the bullet-proof vests, and we use for our soldiers and for our law enforcement officers. Any questions so far? Okay, guys, and I will talk about so much. And if you have any questions, and you are welcome to come to my office or email me. Office hour, and during the office hour, you are welcome to stop by. And as I always say, if if you have time conflict with the office hour, and we can make individual appointments and to discuss some topics you are interested in, or to clarify some points, confusions you might have. Okay, guys, and I hope you have a wonderful day, and I will see you next class. Okay, bye bye.